Hello, grade 10 students. Welcome to the chemistry offline classes. We are starting at unit 2 and today I'm going to talk about the classification of inorganic compounds, and then you're going to be busy with the topic acids. Elements combine to yield compounds. There are two classes of compounds. We have organic compounds and we have inorganic compounds. Let's start by defining organic compounds. Organic compounds are compounds that mainly contain carbon along with hydrogen and oxygen. They may also contain nitrogen and sulfur. I mean that the main constituents of organic compounds are carbon, hydrogen, and oxygen, but there are cases whereby we can find nitrogen and sulfur. Organic compounds are mostly found in the bodies of living organisms, for example, plants, animals, human. That is where we can find organic compounds. Inorganic compounds are compounds other than organic compounds. They do not contain both carbon and hydrogen. It means that they may contain carbon but not hydrogen, and they may contain hydrogen but not carbon. Okay, you cannot find both carbon and hydrogen in an inorganic compound. Inorganic compounds can be found in soil and rocks. That is the classification for inorganic compounds. As we can see, there are three classes: acids, bases, and oxides. So today we're going to focus in acids. Okay, there are two definitions for acids. The first one is that acids are compounds in which one or more hydrogen ions are bonded to a negative ion. And then we can also define acids according to Arrhenius, and he said that acids are substances that dissolve in water by producing an hydrogen ion. Okay, so you may either use the first definition or the definition according to Arrhenius. The word acid comes from the Latin word acere, which means sour. Acids are one of the most important classes of compound in inorganic chemistry, and one of the reasons is because of their leaves. Okay, we can find acids in many components in our lives. For example, in food, I have few examples of acids in food, in drinks, in clean materials, car batteries, in insects, in plants. Okay, so that is one of the reasons why the acids are such important classes. Okay, so I have lemon and orange. We have the citric acid in lemon and orange. In apples and pears, we have the malic acid. In the vinegar, we found the acetic acid. In tomatoes, we found the ascorbic acid. We have acid in vegetables, that is the folic acid. When an insect bites us, it's like he's given to us the formic acid. We have hydrochloric acid in cleaning materials. We have sulfuric acid in car batteries. When we open a cool drink, normally the first thing that happens is a gas being released from that container. Okay, so that gas is the carbonic acid. Characteristic of acids. Acids, they have a sour taste. Okay, it's not sweet, but it is a sour taste. Acids are very corrosive substances. It means that acids can corrode paper, wood, and organic tissues. Acids are very irritant substances. They are soluble in water, they conduct electricity, and in normal conditions they may be liquids or solids. Okay, and then we have few examples of acids that are liquid in normal conditions, and two examples that are for acids that are solid in normal conditions. They have a characteristic order. For example, the nitric acid, it has such an irritant order. So if we put together all those characteristics, for example, the fact of being corrosive, irritant, and conducting electricity, make an acid dangerous substances. Okay, so if you are in a lab dealing with acids, you need to handle there very carefully. Naming acids. Acids are often shown as HA, whereby the H stands for hydrogen and A stands for the acid radical. But not all compounds that contain hydrogen are acids, and I need you to pay attention in that point. For example, methane, glucose, and ammonia, they contain hydrogen. As we can see that methane has 4 atoms of hydrogen, glucose has 12 atoms of hydrogen, and ammonia has 3 atoms of hydrogen. They have hydrogen, but they are not acids. Okay, so not all compounds that have hydrogen atom are classified as acid. When we are naming an acid, we need to pay attention to the type of acid in front of us, whether it's a binary acid or an oxyacid. The binary acids are acids that do not have oxygen, okay, and the oxyacids are acids that contain oxygen. In case of having a binary acid, we use the hydro word, the name of non-metal ending with IC, and then the word acid. Okay, I'm going to give you example of that very soon. For the oxyacids, that are acids that contain oxygen, we need to see whether we only have one possible oxyacid or we have more than one oxyacid. For example, in case of one possible oxyacid, we use the name of the non-metal ending with the IC and then the word acid. In case of having more than one oxyacid, we need to pay attention whether that oxyacid have more oxygen atom than the other one. Okay, so if we have more oxygen acid, we use the non-metal ending with IC. I need you to pay attention in that. But then if we have less oxygen atoms, it means that instead of IC, the name of the acid will end with OUS. So as we can see, the naming when we have more oxygen atoms is the same when we have one possible oxyacid. Okay, so don't forget that. Let's quickly check. We have high HCl. Okay, so is that a binary or an oxyacid? Yes, that is a binary acid. Why? Because there is no oxygen atom. Okay, so according to that schedule, we have the hydro, and then we have the name of the non-metal ending with IC. So we have hydro, then chloric ending with IC, acid. For HI, is also a binary because it doesn't contain oxygen. We have hydro, then the name of the non-metal, that is iodine. So we have iodine, and then the termination IC and the word acid. So that is the hydroiodic acid, and the first one is the hydrochloric acid. Okay, so I think we can try to do the third one. Okay, so that is still a binary acid, there's no oxygen, so we can start by saying that this it starts with hydro. Okay, and then what is the name of the non-metal? That is the sulfur, and then hydro, then acid. Okay, let me just try to use that. So we have okay, we have hydro, we have hydrosulfuric, please, hydrosulfuric acid. Okay, forgive me for that, that is not an easy way to write. Okay, hydrosulfuric acid. And then the last one is still a binary. We have hydrogen and the non-metal. So we have hydro. Okay, we have hydro again. We have you can just write in your book. We have hydro, and then we have bromine. So that is bromic with the ending, the IC termination, hydrobromic acid. Okay, that is how we name that acid. Okay, so hydrobromic acid and then hydrosulfuric acid. Okay, that's supposed to be a U. In case of oxy acids, we can see that we have the presence of oxygen in all of these four acids. So we say that we start with the name of the nonmetal, that is sulfur, and then we need to check whether there is more than one oxy acid, and then the word acid. As we can see, there are two possible oxy acids. So we have the first one with 4 oxygen atoms, and we have the second one with 3 oxygen atoms. So the first one will end with IC, and this one will end with OUS. So we have sulfuric acid and we have sulfurous acid. Okay, you need to pay attention to that, this one and these two terminations. Okay, let me try to use the rubber. You need to pay attention to the how does your acid is presented, whereby you have one or more. Okay, so in that case we have sulfuric acid and we also have sulfurous acid. Okay, so let's try to do this one, the third and fourth. We have 3 atoms of oxygen and we have 2 atoms of oxygen. We already know that the one with less oxygen atom will be having the OUS terminology, and the one with more oxygen atoms will end up with IC. So if we have nitrous acid for HNO2, we are going to have nitric, okay, you're going to have nitric acid for nitric acid for HNO3. Okay, and that is it. A very short lesson. That is your homework. I'm going to upload it via Videna, but let me just explain. You need to read the extra in page 31 that is related with oxy acids of halogen. Please be aware of the oxidation states of your halogen and try to name them. Okay, for example, for uh, the halogens with oxidation state of +1, we have fluorine, bromine, and iodine. So try to name the three of them. Okay, and then question 2, you should give the name or formula of the following acids. We have HbRO3, we have HIO. We should give me the formula for malic acid and also the formula for ascorbic acid. Remember that the malic acid is the acid that is found in the apples and pears, and the ascorbic acid is the acid that is found in the tomatoes. Okay, thank you for paying attention to that class.